Critical particles m and m is going around a circle due to the force of attraction. They are asking you to find the angular speed. All that you know is mv square by a, because the radius is a, is equal to g m square, because this is m and m, by 2a the whole square. So then m and m gets cancelled. So therefore v square by a is equal to gm by 4a square, where a and a also get cancelled. Linear velocity therefore is r times angular velocity, which is a square omega square is gm by 4a. So omega square is gm by 4a cube. Correct? So omega is equal to root of gm by 4a cube. So that is the value. So you got option number D. Let's go to next sum. So next sum is the body is released from a height equal to radius of the earth. So this height happens to be radius of the earth. The body is released from here. They're asking you to find the velocity with which it strikes the ground. So you know the change in potential energy can be equated to half mv square. And the potential energy, never use mgh formula. This gravitation lesson where the potential energy at a height h is minus gmm by the distance from the center, which is 2r, minus the potential on the surface of the earth is minus gmm by r is equal to half mv square. So this will become minus gmm by 2r plus gmm by r is equal to half mv square. So when you take LCM, it's 2r, and so it will become into 2. So gmm by 2r is equal to half mv square. So m and m get cancelled. So 2 and 2 also get cancelled. V square is equal to gm by capital R. V is equal to root of gm by r. I am looking at the options, not working. I know gm can be replaced as small g into r square by r. So therefore root of gr is the right answer. So let's go to next one. So next question is the statement for a planet. If the ratio of mass of the planet to the mass of the earth is increasing, radius of the planet is increasing, which means, see, earth itself is a planet which is revolving around the sun. Okay, if the mass of the earth and the radius of the rotation of the earth is going to increase, definitely the escape velocity is increasing, because the root of 2gm by r or root of 2gr. So then definitely it is dependent on radius of the earth. Okay, and here it's a planet and m by r ratio is there. So definitely it will get affected. So then escape velocity is independent of the radius. Escape velocity is definitely dependent on the planet's weight and radius, mass and radius. It does not depend on a satellite which is revolving around the planet. No, it will not depend. But we are not talking about a body which is escaping from the. So okay, yeah, a body is going to escape from the planet. It's independent of the body's mass, but it's definitely dependent on the planet's mass and radius. That's clear, okay? So yes, so then therefore statement 1 is true and the statement 2 is false. So then the two planets A and B have radii r and 1.5 r, okay, which can be called as 3 by 2 r. The densities are rho and rho by 2. They're asking us to find the acceleration due to gravity. You know Ga, this is A, this is B. G's formula is capital Gm by r square. So capital G into mass of A is density of A into volume of A, which is 4 by 3 pi r cube, by r square, where r square and r get cancelled. Gravity of B, G into rho is rho by 2 density, and a 4 by 3 pi 3 by 2 r cube, which is 3 by 2 whole cube, 3 3 27 by 2 to 4 48 r cube, by this r is also a 9 by 4 r square, where this is getting cancelled. This and the 2 will get cancelled. When you divide this, you know that g and g will get cancelled, rho and rho will get cancelled, 4 by 3 pi r cube. So you are left with a 1 on the numerator, by the denominator is 27 by 8, which is in here, divided by 9 by 4, here itself will become 9 by 2, sorry, again, it will become 2 by 9, so this becomes 3 is to 4, so it's 4 is to 3, so GA by GB is 4 is to 3, so GB by GA is 3 is to 4, so that's the answer that they are asking, okay, so that recording is done. So a planet is having a mass 9 me and radius is 4 re. Okay, then you have to find the new escape velocity. You know, for original escape velocity, formula is root of gme by re, where me is an area mass of the earth. You know, this value is 11.2 km per second. Now the new escape velocity will be root of 2g, m will be 9me, re will be 4re. Let's retain the 2g, me and re as here. So it will be 3 by 2 times the original escape velocity. So original escape velocity is 11.2 kilometer per second. So cancelling it, 5 2s are 10, 6 2s are 12, 6 3s are 18, 5 3s are 15, 16.8 kilometer per second should be your answer. So let's go to, that's option C. Let's go to next sum. So the same question, the ratio of escape velocity of planet. So let's consider this to be the planet and this to be the earth. They're asking the ratio of escape velocities. They've given 16 me, and the planet's mass is 16 mass of the earth and 4 times the radius of the earth. So then escape velocity generally is root of g me by mass of the earth into re by re. But here v dash will be root of 2. We forgot that. Last time I included g into 16 me by 4 re. Just take the 16, this itself is 4, so 2 times ve. So 2:1. So that's the answer. So the recording is done. So let's go to the similar sum like last. So they've given that the planet A and B move around the Earth the same orbit. Yeah, but the mass of A is 2 times the mass of B. So which of the quantities will remain the same? The kinetic energy will not be there because it depends on mass. Kinetic energy half mv square. Total energy, okay, let's go the speed, because angular velocity is the same. Because radius is same, linear velocity is r times angular velocity. Since angular velocity is also same and r is also same, linear velocity is same, and therefore speed is same. But the direction will not be same. That's why they didn't say velocity, that's speed, because the velocity vector is not the same, it could be different. Therefore only speed is the right answer, D is the right answer. Speed is the right answer. Okay, let's explore why can't it be potential energy. What is the formula? Minus g mm by r. That again depends on mass 2m and maybe the potential will be the same. Potential if we ask, not the potential energy. If the option had a potential, we could have marked that. So அதை explore பண்ணியாச்சு. Can I go to next question? So next question you see is the spaceship of mass m which is 2 into 10 to the power 4 kg is launched on a circular orbit around the earth. The additional velocity that is to be imparted to the spaceship so that it will escape from the orbit into the outer atmosphere, which means the given velocity should be equal to, which should be sufficient for the orbital velocity plus the small amount of change which will eventually, this is escape velocity. The given velocity is what is called the escape velocity. So then the escape velocity should be first able to put the satellite in orbit and a small additional velocity which will allow it to escape, delta V. So then escape velocity is formula is root of 2gr E is equal to orbital velocity is root of GRE plus delta V. This small change in velocity is what they are asking, which is root of 2GRE minus root of GRE. So in this root of GRE is common. So into root 2 minus 1. So everywhere there is root 2 minus 1. I just have to put this as 10 and radius of the earth as 10 into 10 to the power minus 3 because I have to convert it into kilometers, and radius of the earth is 6.4 into 10 to the power 3. So this and this get cancelled, 64, and therefore is 8 into root 2 minus 1. Therefore option number D is the right answer. Okay, this is if V is the gravitational potential due to sphere of uniform density on its surface. See, on the surface there is this potential. What will be the potential? On the surface means this will also be capital R. Small r will become capital R. What will be the potential or the center of the sphere? I am going to tell you one formula. Whenever the position vector R is lesser than capital R, which is the radius of the sphere, one special formula is there, which is V of R is equal to G capital M by 2r cube, 2r cube into 3r square minus small r square. This is the formula. This is applicable only when the position, that is when it is inside. You will ask me how this formula came. I'll just tell you a slight outline. I'm not going to go in detail because nobody is going to ask us derivation. But having said that, this is like a Gaussian surface and interior to the Gaussian surface, okay? But this is not electric field, this is potential. Potential now, supposing you are the you are the smallest sphere, he is the outer sphere, and I am here. You have to calculate the potential due to smaller sphere, you have to take into account the potential due to bigger sphere also. So you have to add both of this. To find the potential due to smaller sphere, it's like small r, so minus gm by minus gm by r, that's all. That will be the potential. But due to outer sphere, you have to consider a small elementary width of dx, okay, and of distance x from the center, for which you have to calculate the volume, and you have to that is mass is equal to density into volume. You should write density into that volume, and that volume has to be integrated from small r to capital R, because this width of the outer area is from capital R to small r to capital R is the gap. So while integrating, you will get this kind of a formula. That is why it's very complex, and that is the formula which is V of R. So in this case, they are saying R is 0 because at the center of the sphere. So then therefore Gm 3R square by 2R cube, where R square and R get cancelled, so 3 by 2 Gm by R.
This 3 by 2 V.
So which itself is original potential on the surface, so 3 by 2 V. It's very easy. But however, this formula can be used only to the interior of the sphere. Exterior of the sphere, it's like electric field only. So then minus Gm by, it's Gm by small r depending on the position vector. We don't have to add up anything because the whole sphere is going to contribute to its potential. So we'll go to next sum. So pass. So look at the system, the radii of the two planets A and B, r and 4r, and density rho and rho by 3, ratio of the acceleration due to gravity. So it's the same sum. Okay, so then you can do it, you have already done it before. So let's go to the next question. Teach you the sum, the time period of the satellite. A satellite is revolving around the earth. The time period of the satellite, radius of the earth is r, this is h. Generally, how to write time period is 2 pi r plus h, 2 pi r, by orbital velocity VO. VO itself, is root of Gm by r plus h, root of r plus h. So root of r plus h. So then T is equal to 2 pi into r plus h the whole to the power 3 by 2. By, instead of this, you can write root of gr square. The whole point is you have to get it as T is equal to 2 pi into root of L by g. So put a root, write r plus h the whole cube by gr square. Considering h is equal to r has been given. So T pi into C is equal to 2 pi into root of r plus r is 2r the whole cube by gr square. G itself is given as pi square. So when you write G as pi square, the pi and pi square which is outside will get cancelled. T is equal to 2 into root of 8r cube by r square, which is 8r. So 2 into 2 root 2 is 4 root 2 into root r, which is nothing but root 32r. That's a time period. Okay. So option A. Statement 2. Mother statement 1 mudichirren. The rotation of the earth shows effect on the value of acceleration to gravity. Path odne illa, rotation of the earth is spinning about its axis. Earth is flattened at the edges. We don't know that the earth is flattened because of the rotation. Because it's rotating only, the earth is getting flattened because of the centrifugal force. That we don't know. If you know that, that is what is resulting in the flattening, and the centrifugal force, therefore,
it has variation.
So when it is rotating, there is a centrifugal force, and that is why it's flattened. Hence, the gravity at the poles is different from the gravity at the equator. We know the gravity at the equator is more than the gravity at the
poles.
Gravity, the general formula is Gm by r square. Okay, at the poles it will be rp square, and at the equator is Gm by re square. And you know that radius of the equator is greater than, the denominator here is greater, whereas denominator here is lesser, which is actually signifying that gravity at the poles is greater than gravity at the equator. Therefore, gravity at the poles is greater than the gravity at the equator. நம்ம சொன்னது ஆப்போசிட்டா சொல்றோம். புரியுதா? அப்போ நீ போல்ஸ்ல போயிட்டு வாங்கினேன்னா இட் இஸ் மோர் எக்ஸ்பென்சிவ். ஈக்குவேட்டர்ல போய் சாமான் வாங்கினா மெஷரிங், பட் அது அட்ஜஸ்ட் பண்ணுவாங்க. பட் நம்மளாவே அந்த ஒரு எக்ஸாம்பிள் சொல்றோம். We don't know all that is true, but நம்மளா பேசிக்கிறோம். So the gravity at the poles is greater. That this whole concept of gravity changing is because the radius is changing. And the radius is changing because of the centrifugal force. So I am sure you understood that. So the statement 1 is true, it has an effect. Statement 2, the effect of the rotation of the earth on the value of gravity at the equator is minimum. Gravity at the equator is maximum பார்த்தோமே. Gravity at the equator is minimum, that of poles is maximum. So gravity at the poles is maximum. Correct? Gravity at the poles is maximum, which means given statement is true. False. The effect of rotation of the earth
at the equator is minimum, and that at the pole is maximum.
Gravity at the equator has to be minimum. Gravity, let's explore this. Radius is more on the equator, therefore gravity at the equator should be lesser. நான் மாற்றி போட்டிருக்கேன். இங்கே radius at the poles is lesser, so gravity at the poles is more. So first statement answer is correct only. But the answer on a second statement, second statement, the effect of rotation of the earth on the value of g at the equator. The effect of rotation of the earth on the gravity on the gravity at the equator is minimum. Gravity at the equator is minimum தான். Gravity at the pole is maximum தான். கரெக்டாக தான் இருக்கு. ஆனால் இது ஃபால்ஸ். எஃபெக்ட் பற்றி கேட்குறான். எஃபெக்ட் ஆஃப் என்னது? எஃபெக்ட் ஆஃப் ரொட்டேஷன். அப்புறம் எஃபெக்ட் ஆஃப் சென்ட்ரிபிட்டல் ஃபோர்ஸ். Okay. Okay, let's look at this. Centripetal force is when what is acting away from the center. Centripetal is acting towards the center. So in that poles la pathina, it will be like this. You know, it will be smaller. It will be smaller, where it will be bigger. The R is greater here. At the equator, R is bigger. Centripetal force sort of formula is mv square by R. So R is at the poles is lesser. Centripetal force effect is more. Centripetal force will be centrifugal force mv square by R at the equator. R at the equator is more. The effect of centripetal force itself is less. So their effect will also be. So at the equator the effect will be minimum. Correct? இங்க என்ன போட்டிருக்கான்? Is minimum. At the equator minimum தான் கொடுத்திருக்கானா? அந்த ஆனா ஃபால்ஸ்னு வருதா? எப்படிடா? Centripetal force is mv square. Okay. Statement is incorrect. The effect of Earth's rotation on the value of g is maximum at the equator. This is because the centrifugal force due to Earth's rotation is directed outward and is maximal at the equator. That is maximum centripetal at the equator. mv square by r ache. How is it maximum at the equator? That is maximum at the equator, where the rotational speed is greatest. Rotational speed is greatest. Do you know if r is greater, velocity will be lesser.
And because
R is lesser, the velocity will be. Don't compare it with what we learnt in QVB. R is equal to mv by qb. R is equal to mv by qb. இல்லை v greater இருந்தா r greater m greater அந்த மாதிரி பார்க்காது. அது வேற சாப்டர். நார்மலி ரேடியஸ் பெருசாக இருந்ததுன்னா velocity will be lesser தானே. Where the rotational speed is greatest. Rotational speed and is the greatest. This outward force reduces the net gravitational acceleration one would experience at the equator. Gravitational acceleration, the outward force reduces the net gravitational acceleration one would experience at the equator. Forget about what I said, just listen afresh, okay? Suppose Earth is spinning like this. So the pole means they're talking about just what is here and here. The pole is not even rotating. The Earth is rotating, but pole is not rotating. Whereas equator la inga irukkiradhu inga varudhu, but pole la irukkiradhu is exactly at the pole, not at the latitude. Appdinu consider panninga in the question la. So then, since what is at the pole remains at the pole while rotating, there is no centripetal force. There is no centripetal force or centrifugal force at the poles. Whereas at the equator, definitely you have a centrifugal force which is acting away from the center, and the gravity will be pulling it towards its center. So then both of this will have a net force, and the net force will decrease the gravity. Thus the acceleration due to gravity is less because net force is coming into play, is less at equator. So the effect of centrifugal force reduces the gravity at the equator. So that shows why the gravity at the equator is minimum also, and why the gravity at the poles is maximum. It's a beautiful explanation without numerical that we are able to justify. But this doesn't explain anything about which is situated in the pole at a particular latitude. See, North Pole not exactly North Pole, Northeast, in that it becomes a latitude. That doesn't, this will still spin. So we are not talking anything about that. We don't know yet about that. We'll skip that for the time being. Okay, so we know to answer this. That's been recorded. So according to us, the effect is there on the equator, and that minimizes the gravity at equator. So then, therefore, the effect is true. What? The effect of rotation of Earth. The effect on the poles, it will not be even there. It will be zero effect. Therefore, it is false. Okay, so we are clear. I hope you understood. Okay, so let's go to the next question. That's all. Next page. Time ஆயிடுதாடா உங்களுக்கு? And the two satellites of mass m and 3m revolve around the Earth in a circular orbit of radius r and 3r, the ratio of the orbital speeds. Okay, we have to continue from this sum in the next video. Okay.